Yes, hello, dear students. Today we are going to analyze the motion of the object and identify it from the distance time graph. So we can find out whether the motion is in uniform or non-uniform motion. So before going to the conclusion, we have to take an example, and that example can be, we can take any object. Suppose we take an object A that is moving with an motion along a straight line, and we try to find out the distance traveled after every interval of time, and thus for taking, and we note down the time and the distance moved. So suppose the object starts from its initial position from 9:15 am, and after 9:30 am it covers a 10 meter of distance. In the same way, at 9:45 again we see the distance covered, that is 20 meter. At 10 am it covers 30 meter. At 10:15, 40, 10:30, 50. In this way, at 11 am it covers the whole distance, that is 70 meter. And now we see the distance, the time intervals. So every time interval what we see here, we are noting down the time just after every 15 minutes of the time interval. And now here what we have is the distance, and distance also, if we see from the first position to the second position, it has covered 10 meter, and the second to the third it has covered 10 meter, second to the third, fourth, second to the third 10 meter. In this way, in every 15 minutes it's covering only 10 meter distance. So what we are seeing, that equal intervals of time, the distance covered is also the same, that is equal. And thus we conclude from it that object A is in uniform motion. Why? Because it is covering 10 meters in every 15 meters of intervals of time. So we get it from this that object A is having uniform motion. Now we try to plot these data on distance time graph, and here we are having the distance time graph. The independent value has to be kept on the x-axis and dependent value on the y-axis. Now time being independent value is kept on x-axis and y on y-axis. Now we see from the data that at 9:15 am it is the starting point, that is in the origin it is. At 9:30 it's covering 10 meter, thus we have 10 meter over here. At 9:45 20 meters, and 10 o'clock it is 30 meters. In this way we have at 11 o'clock it covers 70 meter. Now in this graph what we are having is, when we join these points we get a straight line, and this straight line inclined to the x-axis, and thus one conclusion we get from it. Why? Because in the early what we have seen from the data that it is object A is having uniform motion, and thus by plotting the distance time graph we are getting a straight line. Thus we can say that if on distance time graph we get a straight line, that shows that it is having a uniform motion. And in this way, from graph 1 we are getting, the first thing what we are getting is the nature of the motion of the object, that is object A is having a straight line in the graph of distance time, and thus it is having a uniform motion. And the next thing what we can interpret from this distance time graph is the speed of the object. And for the speed of the object we take 2 points. Suppose we take 2 points, the initial point and the point P, and drop a perpendicular on x-axis, and what we have, we get POQ as a right angle triangle. Now distance, the speed is equal to distance traveled by the time taken. Now distance traveled from the graph, what we have is PQ, and time is OQ. So we have the distance is in meter and time is in minute. Then we have PQ by OQ, and POQ is a right angle triangle, and thus angle POQ is the slope, which is also equal to PQ by OQ. And thus we have the on substituting the values of the distance and the time, after calculation we get it is 0.01 meter per second the object is covering. And thus two things we can get from distance time graph, and that is, the first is the nature of the motion, and the second, the speed of the object can be determined from the distance time graph. Now we see the second example. In this second example, suppose we are taking an object B moving in along a straight line, and we see the distance covered in the same interval of times, that is every 15 minutes we are seeing, and the first 15 minutes is covering 12 meter, in the second 15 minutes is covering 7 meter, in the third 15 minute it's covering 4 meter. In this way it's not the same in every 15 minutes, and thus if the distance covered is not the same, in equal intervals of time, that shows that object B is having non-uniform motion. And thus we plot these data on the graph, that is graph 2, and we get from the starting, that is 0, we can join this 0 to this, and 9:30 it is 12 meter, 9:45 19 meter, 10 o'clock 10 it is 23 meter. In this way we see and join all these points, and we see it's not a straight line, it is a curving. And thus if it is not having a fixed slope, that shows that it is not having the same distance covered in equal intervals of time, and thus it shows that it is having a non-uniform motion. So we can conclude from here, if the graph is not a straight line and slope is not fixed from the starting to the end, then it covers unequal distance in equal intervals of time. So we can say that the graph shown is over here is non-uniform motion. So we can conclude that if from the graph, if we get a straight line, it is uniform motion, and if we get in this way, that is a curved line, then we say it's in non-uniform motion. So we can differentiate the uniform motion and the non-uniform motion. Thank you.